When Ryan turns 25, he decides to start a retirement, and he invests $10 per week at 4% compounded monthly, and continues this for 5 years. So compounded monthly, I'm going to start here. We're making weekly in the deposits at 52. We're asking for future value. This is -10. We have nothing else to start off with. Interest rate is 4, and this would be 5 years times whatever 50 times 52, right? That's 260 installments, right? You're making 260 payments over the life of this. If you solve this, you get 2876.64. Okay. Now, I'll tell you how TVM works on the provincial exam. If you make one mistake, it's -1. Okay, you lose a mark, but you still get the second mark for solving. So let's say you get your PY wrong. Obviously, this will be different. Then you still get 1 out of 2. So you basically get 1 out of 2 if you fill this in. That's basically how it goes. Okay. How much interest did you earn after 5 years? Because n is a whole number, and it will always be a whole number unless you're solving for n. Okay, so I'm going to go 1 to 260. If you do this, you get 276.64. And obviously this will be different if you made a mistake in A. If you show me this, sum of interest 1 comma, this number should match whatever you have in n here. If I see that, if I see this matching that, you get this mark, sum of interest 1 to, let's say you got 1 to 52, let's say, right? Because n here is 52 for you. Then I would still honor it. Then you go step, check, right? That means that the step is still correct, okay? I would like to introduce another question here. What if it asked for balance after 2 years? Just add this. It's just a question. You're not going to get any marks for it. But what if I asked you, like, how much does Ryan have after 2 years? 2 years into his investment. Do you remember balance? Do you remember this function? It's right, it's balance, and then you got to go years times PY. So we would go balance 2 years in this case times PY. That is essentially balance. 2 times 52 is 104. If you did that, you would get 1082.24. This is just an aside, just so you don't forget about that function. That tells you how much money you have at any given time throughout your investment. Okay? I could ask for 3 years, 4 years, 1.5 years, doesn't matter. It just makes sure that your time is in years. Okay? So 3 marks so far. Then C, Ryan turns 30 at the end of the 5 years, withdraws the money he accumulated in A, and places it in a TFSA at 3.15 compounded quarterly. How much will he have by the time he retires at 65? Assume he does not make any additional payments. This is very important to assume. We're not putting any regular deposits down anymore. So we have what? Compounded quarterly. We're not making any payments, so payment is 0. Therefore, PY will match whatever CY is. Future value is what we want to know. Present value is what? Well, you got to go all the way up. You got to take, sorry about the zooming out here, you got to take this, right? You withdraw it and you put it into this account. So your present value for me is negative 2876.64. And this has to match whatever you did in A. So I'm not taking any marks off if you transfer whatever you got in A into here. That's actually exactly what I would want to see. Interest rate is 3.15. N I need to go years, right? So from 30 to 65, right? That's 35 years that we're talking about here. So 35 times PY, that gives me 140. Okay? I solve for this. Let me zoom in now. Okay? I solve for it and I get 8,626 and 20 cents. Make sure your calculator is set to end, not begin. All right? TVM solver has to be set to end. Otherwise, your answers are slightly off. Okay? Again, one mistake, minus one. But you still get the other mark for solving. Okay? So if you make even one mistake, the province goes minus one. Okay? So that's how much I have. That's not a whole lot of money, right? But that's how it goes. Estimate the doubling time. Estimate the doubling time. In finance, you should think of rule of 72. So 72 divided by the percentage. So it's essentially 72 divided by 3.15, and that is 22.86 years. Okay, 22.86 years. So 1 mark for that. So this page, you've got 2 and 1 is 3 and another 3. So this page is worth 6 marks. Backside. Okay, so would like to have 7,500 for university. He's going to work 3 years to save up. Saves the same amount each month. Receives an interest rate of 2.5%, compounded monthly. How much will he need to save each month in order to get the goal, achieve that goal? So here we go. Compounded monthly. We're making monthly contributions, right? It's saying we're saving every month. Future value, we would like to have 7,500 there in the future. Payment is in this case what you're solving for. We don't really start with any big amount. Interest rate is 2.5. And we've got 3 years times whatever PY is. So it's going to be 36 payments. He's going to make 36 monthly payments to make this happen. And so we calculate this. If you do this, your payment is 284. That's negative. If you solve for this on your calculator, it is negative. You may or may not include that as long as you have a dollar sign. Okay, so because you solved for it, it's fine to have that negative in there. It's what we expect because you're giving it to the bank. Okay, so if you just circle that, you're good to go. 2 marks. Again, 1 mistake, you lose 1 mark. It's 1 out of 2. Okay. For the bonus, I'm just going to show you this here. You would like $1 million, right? One is, how much would you have to put away if you want to have that in 15 years? How much would you put away in 30 years? And this is the interesting part. Everything else is the same. Compounding periods, payments per year, interest rate, okay? But look at how much you have to put away. If you want to have the same, the $1 million, if you have 30 years to save that up, you only have to put away $1,000 every month. Okay? If you only have 15 years to make the same goal happens, you have to more than triple the contributions. Okay? That's actually, time is your friend. When you're young, if you invest, you have to put in less money of your own to achieve the same goal somebody else would have 15 years, 20 years from now. Okay? This is a fact, right? Why is that? It's due to the exponential growth. It's due to the exponential growth. So the best way to describe this is if you think of an exponential curve, okay, and let's go a long time, and you're like, hey, well, how many years is this? Let's say this is 10 years. Look at your money hasn't grown a whole lot the first 10. But if you take another 10 years, another 10, look at all of a sudden it explodes. Your money goes a lot faster. And let's say another 10 years go by, it goes even faster. So if you only have 10 or 15 years to save, you're not going to get that exponential growth effect. But if you have more time at your disposal, right, then you start seeing that rapid increase in your investment. Okay, so the longer you have, the better off you are, because most of this growth is going to be interest that the bank gives you. They pay you to save. Okay, that's the way to go, guys. That's the way to go. You don't want to just make your money off of your time. You know how when you go work for a company or whatever, most of us get paid for our time. If you invest, it's just sitting there. You're not working at all for that, right? It's just growing on its own. So you work and you have your money grow in the bank, and that's the way to go. That's how you make the most out of your investment. And getting a 6% interest investment is not that hard, okay? And I'll give you that information before we end this course. Anyways, that was a bonus. So if you got that bonus, I'm just going to say +1 max if you got the bonus. So you did B, right? So you should have had the $1,000 and one or something like that per month. If you got that, you get +1, okay? So what are we at total? Two for the backside, 6 for the front. So that would be 8 out of 8 overall, out of 8. And so obviously you can score 9 out of 8 if you got the bonus.